Okay, so let's jump into endogenous growth theory. Endogenous growth theory is important for a lot of different reasons. I mean, it's the sort of more modern version of kind of the classic solo model, and then in a sense, sort of retrofitted, if you will. And it does a really good job of explaining the things that the solo model couldn't explain. So, the solo model kind of gets us up to a particular point, which is basically how sort of intra country growth is determined by capital accumulation, right? But then the solo model does not do a good job of explaining those inter-country differences in that particular process. And so what economists sort of moved towards was, well, okay, maybe there's something more structurally specific about a country's economies that makes a very general model like the solo just kind of naturally fail. Not fail in the sense that it's a bad model, that it doesn't explain economic growth well. It does that very well. But what it doesn't do is explain why we continue to see very poor countries and very rich countries, especially in a world of open, trade flows. We expect there to be some level of kind of technology diffusion to the extent that a parameter, we sort of tend to think about it as being, fairly consistent across countries. At least that if the U.S. has access to particular technologies, then we may believe that most other countries do. That's not really necessarily true. One of those sort of ideas here is that this has to do with sort of capital mobility. We might think about information as a form of capital. And then, therefore, in a digital world, obviously, the mobility potential of information is infinite. That does not change the fact, however, that there are existing barriers to technology diffusion, right? For example, patent law in particular countries can restrict the extent to which technology makes it into other countries. And then the sort of interesting sort of part of that story is that, patent law can be good for individual countries in the sense that they're able to claw back more of the economic benefit of the innovation in their country, but that it also probably makes the entire system a little bit less efficient by erecting these sort of barriers to entry in a way. And if you just think about this in the context of what has become one of the more important macroeconomic stories, especially as it relates to trade, the relationship between especially China and the U.S., but not just China, many other countries as well. And the U.S.'s claim, and there's certainly evidence to support this, of so-called IP theft, right? Intellectual property theft, and which is at its heart a violation of our patent laws. And so it's very difficult for us to try to enforce our patent laws in other countries. And so therefore, we might expect there to be this kind of large scale sort of technology diffusion. But there are enough rigidities, if we want to think about it, we're returning to the language we've used all semester. There certainly could be rigidities in that sort of technology component. And then in addition to that, if we already sort of live in a world where we know that certain socio-political setups, certain production functions even are able to accommodate changes to economic systems, whether they're spillovers from other countries or whether they're shocks from within their own countries. We know that some countries are better able to handle those issues. Some countries are better able to take advantage of technology. There is having the technology and then, in a sense, actually knowing how to use it. And so even in a world of immense intellectual property theft, there's still going to be some rigidities in terms of how much that innovation actually shows up in terms of production functions. So the endogenous growth model basically argues that a very important part ultimately of a country's growth story is not merely technological progress, as the solo model would predict, but in addition to that, we have this sort of institutional quality, as well as institutional atmosphere creation for investment. That is really, at the end of the day, the heart of the endogenous growth model, is basically that some countries are just much more inviting to investors than other countries, whether that's domestic investors or international investors. And as a result, some countries are just much more flush with capital, particularly financial capital, than other countries. And governments within those countries have, in a sense, learned that if you keep the focus on growing investment, that you're gonna get that economic growth as a result. This is, I think, one of the big sort of lessons of the U.S. economy, is that we really started to focus our economic system on innovation, on not maintaining this sort of manufacturing industrial mix, but instead evolving away from it. And in particular, evolving away from it because we were transitioning from lower value manufacturing. And the word value here is not meant to imply usefulness. Lower value just in terms of per unit price, right? A sprocket is cheaper than a computer. And so if your economy evolves, you were making sprockets, now you're making computers. That's going to be a lot about the story of how well your country first sort of promoted the idea of investment and innovation, kept it going, sustained it, such that you then were able to take advantage of all of that potential energy, right? In a way, you can think about this as a potential energy versus kinetic energy. You know, what is the difference between growing economies and non-growing economies? The growing economies have potential energy that they are able to efficiently turn into kinetic energy. The non-growing economies, a lot of them have some potential energy, but they don't necessarily have the systems that are able to translate that into the kinetic energy. I mean, you know, think about countries that are resource rich, that have, you know, some of the most valuable resources on Earth, and have a lot of them, and yet those countries sometimes still continue to languish economically for various reasons. One of the main reasons ends up being sort of institutional quality. Now, the concern, of course, here is that when you start getting into kind of institutional quality in the context of a country, you start to get into sort of judgments about the, you know, cultural and socioeconomics of a particular country. Again, as an economist, I don't care really at all about that particular conversation. I'm merely interested in what makes an economy work versus what doesn't make an economy work. And the one sort of big thing that we know about what makes an economy work is that you have to equip your citizens, and in a sense, you have to equip your country, right? So you have to think about this in terms of infrastructure. You have to think about this, think about how important in the U.S. it has been that we've put fiber optic cable all over the entire country, right? How important has that been to sort of internet access and giving people information, and you know, and as long as they stay off Facebook, you know, that's you know, it can be all net positive, you know, that kind of thing. So, you know, it's not so much that you have the capital, it's not so much that you have the labor, it's also that you have a production function that utilizes those things, and then you have a government, a socio-political system that supports that production function. And the U.S. and a lot of other developed economies, and even recently developing but very successful economies, have, in a sense, sort of figured that part out. You need to have a very smart, hardworking sort of country, and the way that you do that is you incentivize people's seeking of education, people's willingness to give labor hours. You compensate that with high quality of life. So if we go back full circle, you know, to the solo growth model, and this idea that policy ends up being about golden rule and maximizing consumption. All right, so let's just jump into a little bit of math. We'll keep it a little bit light. This is more just, again, kind of to give some thought experiments in your brain and to just motivate some of your ideas. You'll notice that kind of the math complexity sort of goes down here at the very end. We'll still be talking about sort of mathematical ideas, but a little bit less, and just more kind of thought-provoking stuff. So the basic model of the endogenous growth model is the so-called AK model. So if we start with the basic sort of production function, y is equal to a times k, we're going to think about a now as sort of a literal productivity sort of measure. So a is the amount of output per unit of capital. So just think that your production function has capital, and then it has a process through which that capital then is turned into output. The key here is that we are going to think ultimately. All right, one thing I should do is I use the small letters here, but let's actually keep this, because it's technically not it's not output per worker now, and it's not capital per worker now. So let's change these. But that actually is nice because it sort of it also belabors part of the difference in this particular model. So let me just change all. There we go. Okay, so the big thing in the solo model is that we have the concave production function in terms of capital per labor. In the endogenous growth model, we now are going to assume linearity in terms of the production function. Now, this is a big deal because the other thing that this does is this aligns with our use ultimately of something like a basic Cobb-Douglas, because here you get constant marginal product of capital. And so you can go from the sort of Cobb-Douglas, and then you can move that very easily into a linear function that has constant marginal product of capital. So again, it sort of underscores where that's a good place to start. And then we can sort of move and take away, in a sense, the Cobb-Douglas if we need to, but we retain that basic idea of capital and labor as being complementarity, but also, having an interesting bit of substitutability with each other as well. That's always been a really interesting idea to me, is that if you have a multiplicative production function, capital times labor, they're certainly complements, right? You have to have some of both to have any, but they also are a little bit substitutable because you can increase one and decrease the other and get the same output. So you can change your mixes of capital and labor certainly. All right, going back to here. So the graphical representation here is we have this linear investment function, savings times output, and then we have the linear depreciation function. In this particular model, we're not including the population growth and the technological growth here. This is just about depreciation. So it's just the extent to which your economy invests in capital and the extent to which your economy depreciates. Now, the big sort of thing here is that in the linear world of non-diminishing marginal product, what you get is an increasing capital accumulation, because investment is, in a sense, always going to be greater than depreciation. And then it feeds back into itself, such that the change in investment minus depreciation, so investment net of depreciation, is always increasing. And so we get the basic motion equation, which just tells us that the change in total capital stock is equal to investment minus depreciation of the capital stock. So it's in many ways a simpler idea than the solo model. And so why this simpler idea actually does a better job of accommodating the country-to-country differences has to do with the second part here, which is that when you go through and you think about this in terms of growth rates, so that's what we're going to think in terms of endogenous growth. That is a little bit different than in terms of the solo growth, right? In solo growth, we thought about sort of output growing in a sort of over time due to perhaps a change in savings rate or maybe some sort of increase or decrease in depreciation, and we sort of looked at the path of output in that sense. Now we're going to more directly talk about the growth of output. And again, here the idea is we're taking, there's no real consumption here, right? This is just the ability of the country to produce, with the knowledge, of course, that production is certainly going to play a part in consumption due to the generation of incomes, right? So the other kind of interesting thing about the endogenous growth model is that because it predicts lower capital stocks have higher marginal product of capital in the traditional solo, but here, because marginal product of capital is now constant, you no longer have that trade-off between output growth and marginal product of capital. So what you also have in this particular sort of model is that the gains to capital are also always staying the same, so that we have constant marginal product of capital as opposed to diminishing marginal product of capital, right? Because in the basic solo model, when you have the concave production function, investment that moves you along that production function to a higher level of capital and a higher level of output is also going to translate into a lower level of marginal product of capital. So the gains to capital actually decline in that model. Whereas in the endogenous growth model, what we're essentially arguing is that the gains to that capital investment are constant. So in a sense, there is no diminishing returns to investment. Therefore, countries find it in their best interest to just invest as much as possible. Now, the puzzle, of course, with all of this is going to be how do you keep the requisite level of investment in a low savings world, right? How does that sort of work? And the way that countries like the U.S. get away with it, of course, is because the lack of savings in the U.S., which puts upward pressure on our interest rates, which we would typically expect to cause a reduction in investment and potentially befuddle this particular story. But investment can go outside. And so we have this capital flow story where in the U.S. In particular, we have very high imports relative to exports. And in a sense, that has enabled us to continue at the growth rate that we otherwise would not have due to our relatively low savings, right? Because at the end of the day, in the endogenous growth model, the growth of output here is a function of the savings rate, the per unit productivity of capital, and then depreciation. So the big question here is about capital and the nature of what capital does to output when you increase it, right? So is it diminishing? Is it constant? And so there's a big debate here in terms of sort of how we think about capital in general, but less debate when you start thinking about different types of capital. So in economics, we sort of think about there being sort of three types of capital. You have natural capital, which is like natural resources, right? So oil, water, wood, forest, things like that. That's natural capital. Huh. Sorry, my for some reason my whiteboard is not updating the way that it normally does. Let me do this real quick. Go back here. Okay, my apologies. It's back now. So we tend to think in terms of like three types of capital, right? Natural capital, physical capital, and human capital. The nature of natural capital is that it is typically sort of diminishing returns. For example, when we burn coal, the more and more coal that you burn, you get more electricity, but you certainly get sort of this diminishing returns to coal burning for various reasons, cost, environmental degradation, so on and so forth, right? Oil kind of the same way. Now, there are sort of natural resources, for example, solar or wind power that do not have these sort of diminishing returns. But historically speaking, we've tended to think about natural capital as kind of naturally having diminishing returns. Physical capital, very similar story. In physical capital, you're sort of constrained by physics. In an interesting way, physics almost implies sort of diminishing returns of production, especially in a depreciating world. When physical capital in particular, is constantly depreciating, you're going to get diminishing returns. The big one here is that human capital conversation, because human capital is the one that I think a lot of folks kind of believe you don't have diminishing returns. So basically, like every person that you educate generates constant benefit to your economic system. And it's not the case that as you educate more and more and more people, that the benefits of educating those people start to decline in the same way that if you use all of your capital at once, you're going to use it inefficiently. And so the argument here is that the marginal product of capital for humans is constant, whereas for both natural and at least most physical and most natural forms of capital, we have diminishing marginal returns. Now, again, I think the promise of alternative energy sources and the potential for them to be increasing returns is certainly exciting, right? I grew up as a Star Trek guy, as sort of really infatuated with a world in which we've sort of moved past economics because of advances in science, which allow us to essentially have infinite energy. I still very much believe in the possibility of that kind of scientific world. We're not there yet, right? Natural gas is not infinite energy. Even nuclear, which is certainly an energy I would tend to prefer, is also not infinite. So anyway, so human capital is the increasing one. So if we need a constant returns to capital story to make economic growth make sense, why do some countries grow and other countries do not? Then the human capital story makes a very, very compelling story. So basically, if you just sort of ask the question, for example, what's the education rate of an economy? Well, how many people can read? What's the literacy rate? Those sorts of questions, perhaps not surprisingly, have very, very big effects on the question of what does and what does not grow an economy. So you can try to do everything you want with just the K and the L part of the production function, but because ultimately in the endogenous growth model, the savings combined with the per unit productivity of capital means that you governments sort of, if they want to generate lots and lots of investment, then they need to sort of focus on lots and lots of technological improvement. Now, I think this certainly opens up us to the story of, well, if every single country does this, then who eventually is going to make those sort of quote unquote low value manufacturing things, right? Well, isn't everybody eventually going to be making computers? And the argument actually here is not that everyone eventually is going to make the same technology, but rather that over time, there's going to be this sort of symbiotic positive spillover where now the relative comparative advantages just pile up so much that the economic systems of the world, in a sense, take advantage of each other's endogenous growth potential. So that basically the endogenous growth also belies its own type of comparative advantage. And so now we get into sort of this interesting territory of maybe we will have these much more sort of regional specializations, sort of a combination of manufacturing, service sector, raw material extraction that is a little bit more kind of regionally specialized. And you're already kind of moving, in this direction quite a bit. There's been this sort of reemergence of, the sort of textile belt. In the United States, our textile belt used to be in North Carolina and South Carolina. Now the textile belt is largely in countries like Bangladesh. But they are becoming good at that. And what's occurring and what we're starting to see is that they are experiencing positive spillovers due to that technological diffusion and the fact that in those countries, they're just better equipped now to accommodate things like population growth as well as technological progress. And at the end of the day, the main way that they've learned to accommodate this is through increases in human capital and investments in universities, investments in primary and secondary education, basically giving people the tools that will allow them to find their specializations seems to be a big reason why countries grow and why others do not. This is why I think for economists, we believe very strongly in the notion of economic opportunity, And the countries that provide their citizens with the greatest access to economic opportunity will also end up being naturally the economies that tend to grow the most. And because the way that you grow economic opportunity the most is you give people and you equip them with the tools and skills and knowledge necessary to take advantage of, an economy in 2025. And not surprisingly, an economy in 2025 is a highly technological advanced economy, even in those countries that are manufacturing heavy, right? China nowadays, they don't simply make heavy manufacturing light manufacturing in China because it's cheap labor. That's part of at least the initial story. But now China makes things because their manufacturing is just better specialized. They make those things better there than anywhere else. It's about technology. It's not so much about low wages anymore. That's, I think, a very interesting part of economic systems moving forward. And so now we start thinking about sort of separating capital into different categories, separating industrial sectors into different categories, research versus manufacturing. But of course, the idea is that they have spillovers into both, that research informs manufacturing, manufacturing informs research, that we have this sort of symbiotic relationship. Again, the United States did this fantastically, right? In the United States, what we did really well is we created these public-private partnerships, universities, working with industry to improve engineering, to improve systems, materials, processes, everything conceivable to sort of take advantage of the human capital of the United States. And if you look at the countries that have succeeded economically, they also happen to be countries that seem to have taken great advantage of their human capital. So that's really ends up being kind of the story on the endogenous growth model. But I want to kind of leave you with sort of something that we had mentioned previously in a previous lecture earlier in the term, and that was this idea of creative destruction. The one thing that we have to keep in mind is that when economies grow, and especially when economies grow over multiple growth cycles, so in that kind of starts and spurts, that there's going to be economic misery. There is no way to avoid economic misery, even in rich economic countries. And in some sense, one of the things we've seen in rich economic countries is that those economic downturns end up feeling, in a way, almost comparatively worse, because the loss in wealth ends up being comparatively worse than smaller countries. Now, I would not argue it's actually worse, but in an expectations and perceptions driven world, I think that certainly matters. And so I think having a more honest conversation with people about the realities of economic growth, and if your economy is growing, and if it is growing fairly rapidly, you're going to have a lot of creative destruction. So as a result, you really need to make sure you're improving people's skills. That when it comes to investment, you're not just focusing on investing in the actual putting together of things, but that you're also investing in the research and know-how to improve and inform those new and then, of course, already existing processes.